Hey, here we go again. We just keep going like the Energizer Bunny. Go, go, go. It keeps going and going and going. I'm assuming you guys know that commercial. Hey, math video. Alien guy. Yes, alien. Hey, let's go ahead and get started, my friends. I do believe this is recording. Let me see here. Are we recording? We are. Yay! Okay, I guess I can put that back. Dun, 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 dun. All right. And we put you down there. Adios. Okay, here we are. We are talking about topic B, making like units pictorially. This is the last lesson on this topic. We will be having a part A and part B. This is part A. So let's go ahead and get started here. First things first, we want to take a look at this problem. It says here that Cassandra, hey, weeded 1/6 of the garden. And Tatiana weeded some too. Nice that you could help. When they were finished, 3/4 of the garden still needed to be weeded. It's probably because they were talking, you know, how it is, you know. Tatiana, Cassandra, you know. Anyway, what fraction of the garden did Tatiana weed? Okay, since we already know the amount that Cassandra actually weeded, it tells us right there, 1/6. So the question wouldn't be how much she weeded because we know that. Okay, it's what we're looking at here. And again, makes me think of the old R, and this is not a code word. Please don't be confused. Remember, this is for read, draw, and write, and we're going to address that. But let's go ahead and start off by doing, what am I looking for here? Oh, not that, that's for sure. Okay, because I need to go ahead and I'm going to show the amount that Cassandra weeded, okay, which she basically did, it looks like sixths. So I should be able to come down and put that right in there like such, like so. And we'll move it this way a little bit. Nice. And then, of course, the 3/4 of the garden is how much wasn't weeded. Okay, it had been completed, or we'll say is just the amount that was left over. So what I'm going to do here is, do I have, will this work? Oh, this won't work for this, will it? Oh, I guess I can make it work. Yay! It works for me. Okay, make it a little bit smaller. There we go. And just do 2 of them. Okay, so this shaded amount here obviously indicates the amount that still needed to be weeded. This here 1/6 shows the amount that Cassandra had actually weeded herself, and Tatiana, well, is an amount we don't know, fraction. So again, we can't work with these units because the denominator, they're not like denominators, therefore we need to make that happen. And probably the easiest way is to simply turn that into 24ths by putting that into quarters and then 6. Make a copy of that. Okay, and you let go. Thank you. Oh, I thought it was all connected together. It was not, huh? Oh, did I undo it? Maybe that's what happened. Okay, so I just want to make another copy of this so I could take this. Now, this is 3/4. So probably, I guess the easiest way here is to kind of think of it this way. We're adding 2 amounts. We need to add the 1/6 of the garden that Cassandra did, and then we're going to go ahead and add the 3/4 that never got finished, because what's left would be Tatiana. Doesn't that make sense? Because she didn't do this part, nor did Cassandra, but Cassandra did this part. So we have our 1/6, and now we need our 3/4. Well, if you look at this, this is 4 out of 24, okay? And so we could actually rename these, which would be the easiest way to do this. So we're going to go ahead and name this as 4 over, and then we have that 1, 2, 3, 4, 5, 6. This is just one way you can figure out 1, 2, 3, 4. We made 24ths. Okay, and then over here we have our 3/4. However, we could also take the same amount here, and let's do that, and show that that's in 24ths. So if we have 6 times 4 is 24, then 6, 6, 6 here would be 6 times 3, which is 18. I'm going to go ahead and get 18. So now we have 18 24ths. That's how much had been completed. Now when we add these together, this is Cassandra. Okay, I'm going to write her name right here. And then this is the amount that did not get weeded. If we add those together, we end up with 22 over 24. Now, the whole garden would be one whole. Therefore, a whole garden would be 24 over 24. And the amount that we know that Cassandra and the part that hadn't been weeded was 22 over 24. Well, a simple subtraction, and we can figure out how much Tatiana did. And if she worked very hard, we'll find that out too. So 24 minus 22 is 2 over 24. Therefore, to put it in simplest terms, we can look for a common factor that the numerator and the denominator have. And those two factors, remember, when they're multiplied together, they'll give you this number. Well, 2 times 1 is 2, so we could divide out a 2. Here we have 12 times 2 is 24, so we could also divide out a 2. We say that they have a common factor. Therefore, we end up with 1 over 12. And therefore, the amount that Tatiana actually did was 1/12. Doesn't seem like much, does it? But however, that's 2 out of 24. So out of the whole garden, you could kind of think, okay, Tatiana did this much in the garden. Okay, that's how much of the garden got left with all the weeds. And then this is the amount that Cassandra did. And we did that by showing an area model. Okay? Now, we should be able to add those all together and, of course, get our 24 out of 24, the whole garden, 1/12, which we'll just say is 2 24ths plus the 18 24ths, which was left unweeded. And then, of course, Cassandra and her amount. And that's how we do that. And that's how we do this. Now, let's go ahead and look at this problem, though, in another way. Because some of you have probably gotten pretty good at seeing how these common denominators have helped us in solving problems. So there might be another way you might want to show this. For example, you could, and I'm just going to show this whole thing as your garden, right? We'll show this is the garden. If you notice, the same problem is up above. And this is our whole. And we can kind of think about breaking it up into parts. For example, we could show the amount that Cassandra did. And since her amount was smaller here, we could show that as maybe our 1/6. Okay? So this here we'll say is 1/6. This is not drawn to scale, so that doesn't mean this is exactly 1/6. We're just estimating here. To show it, and that should be a capital C, capital letter, Mr. Wara. Okay. You got me, guys. You got me. What can I say? So if she did the 1/6 here, then we need to show another amount. And that would be probably a larger, pretty good portion, which was the part that was unweeded, right? And that part was 3/4. And so this part I'm just going to put down here, unweeded. Okay? This last part is the amount that Tatiana did. Okay? So I'm just going to write her name over here. What's, I think, kind of significant to see here is that we've kind of set it up similarly, except that we haven't done the area model. We've done the tape diagram showing that, well, this is the whole garden, and we have 1/6, which was Cassandra's right here, okay? We have 3/4, whoa, woo, that was kind of cool. 3/4 was the part that was not completed, and then, of course, lastly, we have the unweeded part, which we don't know, which is Tatiana. So let's go ahead and write the problem like this, then. If we were to put, and I'm going to just bring this like so, so one whole garden, right, complete, minus the amount that Cassandra did, okay, and then minus what was left over, should give us, right, the amount that Tatiana did. So let's go ahead and write it this way then. Let's look at the equation this way. 1 minus 1/6, that lets you know that how many would be left over would be 5/6. Does that make sense? 5/6 plus 1/6 would be our whole. So we just kind of subtracted that. Now we're going to subtract our 3/4, and of course that's going to give us the amount that Tatiana did. Okay, we'll write her name here. So now we're just basically needing to find that denominator that they have in common. Now we have a 6, we have a 12, and a 4. Now in the previous one we actually shown that it was 24. And when you multiply these two together, that will give you a common denominator. What can also give you a common denominator is by finding the multiples of that number. So if I were to just do 6, 12, and count by 6s, and then count by 4s, 4, 8, 12. I could also use 12 because they're both, well, they're both, 12s are multiples of both 4 and 6. But let's go ahead and just keep it like we had it, 24, because that will work. And then we have 24 here. Now we're subtracting. And then, of course, 6 times 4 is 24. So 5 times 4 would be 20. That's how I did that. 6 times 4 is going to get me here. So I'm going to go ahead and multiply that top by that same amount. This might be kind of new for you guys, but this is a skill that typically is taught, but this program doesn't always have you do it this way. 4 times 6 is 24, so you multiply that by 6, we get 18. Now if we subtract, we get our 2 over 24. And we're right back where we were. 1/12 if you divide that by 2, and you divide that by 2. Seem pretty easy, doesn't it? It does, I actually kind of think so. Now that was the same problem, just done in 2 different ways. Let's move on to another problem here with Bukumi. Yay! Okay, now it says Bukumi, she spent 1/4 of her money on a pack of pens, 1/3 of her money on a pack of markers, and 1/6 of her money on a pack of pencils. My goodness. Okay, so basically, oh, I don't have a question here. I'm sorry, I meant to put that in there. Let's go ahead and put that question in here. Should say, what fraction of her money is left? All right. Now we have that in there. Ooh, we got buried. Yay. Okay. Well, let's go ahead and look at it this way. First thing is I'm going to just kind of get us in the habit of moving straight forth, okay, by looking at and rereading the problem. So it says Bukumi spent 1/4 of her money on a pack of pens. We could show quarters, right, by bringing this over here. Now we have quarters. And we could show 1/4 is basically going to be that amount. Now we look at it, it says 1/3 of her money was spent on markers. So we could take 1/3, and if we do this, you can see that we've created thirds, 3 equal pieces. As long as they're equal, that works, right? So that means I could put him here, or let's see, which one did I use? Probably this guy, yeah. And, oh, it was only 1/3. I was getting so excited, I wanted to put another one in there. Okay, so that's 1/3. And then 1/6 of her money, bring this on down, okay? And that's going to be the markers. Okay, see if I can write that a little bit faster. So now you can see all these different units. What fraction of her money is left? So after she spent all this, we're not actually going to be, well, they don't want to know the total amount of money that she spent as much as this, how much is going to be left. So there is kind of a 2-step problem here, because at first it's like she's going to have a total amount. We're going to need to add the amount of money that she spent on these different items and then figure out how much was left. Go ahead and remember this. Looking at this, I can see that 6, 4, and 3 will go into 24, and I know this because 6 times 4 is 24, and 8 times 3 is 24, and so these are basically 24 is a multiple of all those numbers. What I'm going to do here is, since I have my 6th over here, I'm just going to go ahead and put my 6 down here. So now I have my 6 just like I have up above. I'm also going to put on my thirds. Now thirds are kind of neat because look, they're going to end up sitting on top of these two, which doesn't play a huge role here because I already have my thirds listed. See that? See how they end up? So I'm not going to use that for that, but I'm also going to get my quarters. Now, what do I have? 1, 2, 3, 4, 5, 6. 6 times 4 columns, my 24. So even to speed this up a little bit more, I'm going to do this. I'm going to go ahead and group, and then make a copy, 2 of them. So now I have my 24s, just like we've been doing in previous lessons. Now if you look, no, don't do that. Okay. Why does my voice always get high when I do that? It's like, hey, don't do that. All right, so I bring this down here, and now you can see the same quantity. Now we can write our fraction for each. See, we had 6 times 4, so look at, there's 6 out of 24 for the pack of pens. Here we have 2, 4, 6, 8. We have 8 out of 24 for our pack of markers. And then here we have just 4 of 24 for our pack of pencils. And now what we can do is we can go ahead and determine how much is that. Well, 6 plus 8 plus 4? Well, 12 plus 6 is 18. I'll put it out like this so you can see exactly what I'm doing. And then we have 4 over 24. And again, I said 12. I said 18 over 24. So 18 24ths. Looking at this, I can see that, well, there's 24 of 24 for one whole. I'm just subtracting the difference. So 24 over 24 would be my one whole minus my 18 24ths. And I have, looks like to me, 6 24ths. And we can divide out a common factor because 6 times 1 is 6, and then 6 times 4 is 24. Therefore, giving us a reduced fraction of 1 over 4, which is 1/4. So 1/4 of the money, fraction of the money is left that she spent. Okay, now that was one way that we could solve this problem using the area model. Okay, again, I want to move on. I want to try to go ahead and do it with a tape diagram now. What we do with a tape diagram is similar, just like what we did in the other problem. That whole strip here is going to represent all of her money. Okay, all of Bokumi's money. Now we have that. Now we can go ahead and show this in the pieces. Like we have the quarter of her money, and since this is a half, the quarter is actually about right here. And I'm just estimating. And this shows you the amount that she spent on pens. And then, of course, we have 1/3 of her money in a pack of markers. And a third, well, looking at this, we'll just say it's like that, approximately. Not that it's exact, but it has to be more than a quarter. And then that's going to be markers. And, of course, we have a small little amount here. Looks like about a 1/6. Remember, that was her pencils. And then, of course, the remaining amount, remember, that's what's left, the money that she has left. So this is just showing you the tape diagram. Well, again, one whole amount of the money represents 1. We just subtracting of them. We're subtracting our 1/3 that she spent there, her 1/4 that she spent on the pens, the 1/6 that she spent on the pencils. Okay, so that should give us what's left. A couple different ways you could do this. I'm looking at 1 minus 1/3. You might say, yeah, I know there's 3/3 in one whole, therefore I would have 2/3 left if I subtracted that. And then I'd have minus my 1/4 minus my 1/6. Okay, see how I'm doing that? Now basically here, probably the easiest way here, maybe we can join forces. If we're subtracting all of this here from that 2/3, here we have 24ths, and that would be 6 24ths here. Maybe we want to go to convert all this into something easier, like so here's 2/3. So let's go ahead and make that that's 2/3 and 24ths. If you didn't know that, let's look at it this way. If we wanted to make them into 24ths, this is how we could write this. 3 times what gives you to 24? Okay, so then if that's 8, then this is going to be 16 24ths. And then I'm going to subtract, because that was our whole. I'm going to subtract this amount. Well, 1/4 we already determined, same thing. 1/4 equals how many 24ths? 4 times 6 is 24, so that's going to be 6 24ths. And then we're also going to be subtracting over here 1/6 looks like, and 1/6 here, if we put that, equals 24. That's going to be 6 times 4 is 24, times 4 up here is 4. And I know I'm doing this kind of fast here, but if you know your times table, it'll make a little bit more sense. 4 24ths. Now you can see, well, 6 and 4 together equals 10 24ths. Okay, so now I'm going to show this as 16 24ths minus 10 24ths, because that's what's added. Remember, we're taking away from this because this was our initial whole, and I took off the 1/3 off the right away and got left with 2/3. Okay, then we're taking 2/3 and subtracting the other two numbers here. And so that leaves me with the 6 24ths, or again, the 1/4, which is what we were looking for. Okay, I hope that made some sense. This basically is, like, again, a 2-part video, just trying to go through this a little bit quicker so the video wasn't quite as long. No fancy little things, you know what, jumping out at you, but you know what I will do? I'll draw a little happy face. Yay! Alright guys, take care. Live long and prosper.